Page 3. Now we're going to get some practice with this process, which we call completing the square. and let me point out that we have 1x squared for all the examples on this page. There are 6 here that have 1x squared. We'll deal with things like 2x squared and 4x squared and such later. Okay, so we need the magic number to add here so that this becomes a perfect square trinomial, rewritable as x plus something squared. And all we do is we take half of 12. Half of 12 is 6. And then 6 squared is 36. And that's what goes there. Now this is a perfect square. What's it equivalent to? Same variable, same plus or minus sign, and always half of that. It's always the 6. X plus 6 times x plus 6 would make the x squared plus 12x plus 36. Slide over to number 11. Half of negative 14 be negative 7, and negative 7 squared is 49. That's what gets added there. And what goes in the parentheses? Same variable, same plus or minus, minus this time, and half of that. Okay. And again, let me just make it really, really clear. X minus 7 times x minus 7, which is what that 2 means, is exactly the same as that. Okay? Now, half of negative 5, I don't want to use a decimal. You can use a decimal, feel free, but I'd rather use a fraction. I just put it over a 2. There's half of negative 5. When I square this, what do I get? Positive 25 over 4. That's what gets added to make this a perfect square trinomial. Now what goes in the parentheses? The same variable, the same sign, and half of 5, I'm going to write 5 over 2. If you'd rather write 2.5 or 2.5, that's okay. But this will be easier to work with in later steps, you'll see. Getting ever so slightly more difficult, there's the middle coefficient, 7/3. I want half of 7/3. So one way to talk our way through that is say a half of a number is the same as a half times the number. So a half of 7/3 can be found by multiplying the fraction 1/2 times 7/3, and you get 7/6. Now don't forget we square that to see what to add at the end. So squaring 7/6, we get 49 over 36. Okay, now sing the song along with me. What goes here? The same variable and the same plus or minus, and half of 7/3, as we said a minute ago, is 7 over 6. Okay, so this is just practice in completing the square. Now we're going to see down here how we actually use it to solve these equations. If you add 24 to both sides and have 0 over here and factor it, you're going to get 2 solutions. And that's fine, but we're using this method for the quadratic equations that we're now going to get handed that don't factor, that have answers that involve irreducible square roots. You'll see what that means very shortly also. We're getting more powerful in our ability to solve quadratics is what it comes down to. So, solving by completing the square, we start like this. We have our x terms on one side of the equal sign and any constants on the other side. And then the first thing to do is make some physical space right here so that we can add something. And what are we going to add? The same idea as we applied up above. It's a 1x squared, so we take half of that, which would be 5, and then square it as 25. I add 25. If I'm adding 25 to this side of the equation, I better add 25 to the other side also. Okay? Now, why did we do all this? Because now I can rewrite this as what? X, same sign, half of that. And what do we have on the other side? Negative 24 plus 25 is 1. And now we're back to like what we were doing on page 1, I guess it was. Could take the square root of both sides, take the square root of the parentheses squared side to get rid of the parentheses. On the numerical side, I say plus or minus. Okay? Now, the square root of x plus 5 squared is just good old x plus 5. Square root of 1 is just 1, so I have plus or minus 1. Almost finished. I want to get this plus 5 out of here, so I add negative 5 to both sides, and I put the negative 5 right in there after the equal sign before the plus or minus, and I write x equals negative 5 plus or minus 1, which means what two numbers? Negative 5 plus 1 would be negative 4. Negative 5 minus 1 would be negative 6. And both of these values, if you insert them in the original, will give you a negative 24. Oh. Let's try number 15. Got all the x terms on one side, the loose number on the other side. I'm making a big parking space here for whatever we're going to add. So half of 4 is 2, and 2 squared is 4. So that's what goes here. Now don't forget, if you're adding something on one side of an equation, you want to add the same amount on the other side of the equation. So now this becomes x plus half of that. See, x plus 2 squared is equivalent to x squared plus 4x plus 4. On the other side, 45 plus 4. Here we got a nice perfect square number again. So take the square root of both sides. And as I often say, you do not have to do as much writing as I'm doing. Make sure if you write everything out, you're less likely to make a mistake, but you might skip a step or two and do mentally. Square root of the square of x plus 2 is x plus 2. On the other side, we have plus or minus 7. And then if I add negative 2 to both sides, I'm going to have x equals negative 2 plus or minus 7, which means negative 2 plus 7, or negative 2 minus 7. These are the real two answers. By the way, that tells me that I could have taken away 45 from both sides. Just think of this as entertainment. Haha. Can we factor this? What two numbers add up to 4 and multiply out to negative 45? Plus 9 and minus 5, right? Is that how that factors? Yeah. What are the solutions here? Negative 9 and 5. Negative 9 and 5. Negative 9 and 5. Aha! See? So, yeah, we could have solved this by factoring, but we're practicing using this method for the stuff that does not factor. And there's plenty of those out there, quadratics that don't factor. See you in a minute on the next page.